Hi there, and welcome to this lesson. In this lesson, we'll be learning about sequences and series, okay? And we'll do a brief introduction, then we'll learn about arithmetic progressions, and finally, we'll learn about geometric progressions, okay? And as the lesson progresses, if you have any issues, if anything comes off as unclear, please feel free to get in touch. You can do so via phone, WhatsApp, Skype, or Facebook, and we would be happy to help. Alright, you can also visit our website. We do have a lot of exciting features on there. And yeah, let's jump right into the lesson. So sequences and series, we start off with a brief introduction. Okay, introduction to sequences and series. So a sequence is a set of numbers arranged in a manner in which they follow one another, okay, with each number obtained from the preceding number following a given relationship. For example, you could have 3, 10, 17, 24, 31, 38, and so on. And basically what you notice is you have the following number obtained from the number before it, i.e. you have 10 obtained from 3 by adding 7, okay, following a given relationship. And the same way you have 17 obtained from 10 by adding 7. You keep adding 7 as the sequence progresses, okay? And in the same way, you have 4, 20, 100, 500, 2500. You have 20 obtained from 4 by multiplying by 5, and you have 100 obtained from 20 multiplying by 5 as well. So it's a fixed relationship as the sequence progresses, okay? Now there are two major types of sequences, okay, and these are the arithmetic sequence and the geometric sequence. And I'll tell you that the two examples we have, the first example, 3, 10, 17, 24, is an arithmetic sequence, and 4, 20, 100, 500 is a geometric sequence. So let's understand what arithmetic sequences or arithmetic progressions are. Okay, so we start with arithmetic progressions. An arithmetic progression is a sequence that progresses using a difference. Okay, for example, you have 3, 5, 7, 9, and so on. You notice we're adding something as the sequence progresses, okay, and in this case we're adding 2. So we start off with 3, and we have 3 plus 2 equals 5, and we have 5 plus 2 equals 7, 7 plus 2 equals 9, and so on. Okay, now we can find the value of a given term in an arithmetic sequence using the formula Tn equals a plus n minus 1d, okay, where a is the first term of the sequence and d is the common difference of the sequence, i.e. the number that we're adding as the sequence progresses, and n is the nth term of the sequence. For example, if I ask you to find the 10th term of the sequence, n would be 10, okay. We can also find the sum of all the terms in an arithmetic sequence up to a given term using the formula Sn equals n over 2 multiplying 2a plus n minus 1d, okay. And similarly, n is the term, the given term. For example, if I ask you to find the sum of all the terms of an arithmetic sequence up to the 7th term, n would be 7, okay. And a is the first term of the sequence and d is the common difference, okay. And let's talk now about geometric progressions. Now, a geometric progression is a progression that progresses using a ratio, okay. So an arithmetic progression progresses using a difference. A geometric progression progresses using a ratio, okay, using a multiplier. All right, and basically we have something like 3, 6, 12, 24, and so on. What we have here is we have a geometric progression progressing with a ratio of 2, okay. So we start off with 3 and we multiply by 2 to get 6, we multiply by 2 to get 12, we multiply by 2 to get 24, and so on. And in the same way, we can find the value of a given term in a geometric sequence using the formula Tn equals arn minus 1, okay, where n is the term we're looking for, and a is the first term of the sequence, and r is the common ratio, i.e. the number that will multiply with as the sequence progresses. And similarly, we can find the sum of all the terms in a geometric sequence up to a given term using the formula Sn equals a 1 minus r to the power of n divided by 1 minus r. Okay, so that's a bit about sequences and series. I think we can go ahead now and solve an example. Okay, so example 1. And example 1 says find the 15th term of the arithmetic progression 5, 8, 11, and 14. Okay, and to do this, the first thing we need to do, we need to identify the relevant formula. Okay, so we've been asked to find a term of an arithmetic progression, and the formula we need to use here is we need to use Tn equals a plus n minus 1d. Okay, so we have Tn equals a plus n minus 1d. Okay, and then the next thing we need to do is we need to identify our parameters. Okay, so we need to know what a is, what n is, and what d is. So we have that in this case a is 5, okay, because 5 is the first term. The first term of this progression is 5, so we have that a is 5, and then we have that n is 15 because we've been asked to find the 15th term of the progression. Okay, and then we have that d. To find d, basically we're looking for the difference. D is 8 minus 5, which is 3, or 11 minus 8, which is also 3, or 14 minus 11, which is also 3. Okay, so the common relationship, the common difference. Okay, so we have a, we have n, and we have d. And the next thing we want to do is we basically want to put all of that into our formula. So we have that Tn, our formula is Tn equals a plus n minus 1d, and basically we have that T15 equals 5 plus 15 minus 1 times 3. Okay, because a is 5, n is 15, and d is 3. Okay, and T15, because we're looking for the 15th term, equals 5 plus 14 times 3. Have that T15 equals 5 plus 42, and finally we have our answer. T15 is 47. Okay, so if you decide to write out this arithmetic progression, okay, if you continue to write this out up until the 15th term, okay, so this is our first term. Our first term is 5, second term is 8, third term is 11, fourth term is 15. If you continued adding 3 up until the 15th term, you will arrive at 47 as your 15th term. Okay, and that is how you solve for a given term in an arithmetic progression. Okay, let's move on.